Hey everyone, today we're jumping right into a crucial skill for modern development in this explainer, Docker image optimization. We're going to take those bloated, inefficient Docker files and transform them into lightning-fast, production-ready artifacts. Whether you're setting up local environments or deploying at massive scale, the techniques we're covering today are absolutely non-negotiable for modern developers.
So I want you to ask yourself right now, is your perfectly optimized tiny little app secretly generating a massive, slow 20 gigabyte Docker image? Because honestly, it happens way more often than you'd think. A bloated image doesn't just waste hard drive space, it destroys your build times, clogs up your CI/CD pipelines, and even worse, it can introduce serious security vulnerabilities by packaging sensitive files and environments that have absolutely no business being in production.
All right, here's our roadmap for today. First, the big Docker image problem. Second, choosing the right base image. Then, proper use of layer caching, using Docker Ignore, and finally, the magic of multi-stage builds. Let's get right into it.
Starting off with Section 1, the big Docker image problem.
Okay, let's look at exactly what happens when we write a, bad Docker file. Here's our starting point. We've got a super simple Node.js TypeScript app, literally just a basic server returning an OK status. But when we build it using a standard Ubuntu base image, our resulting Docker image comes out to a staggering 585 megabytes. For a simple Node app, that is completely unacceptable.
So why is this 585 megabyte image exactly what we want to avoid? Let's peek under the hood. By using a standard Ubuntu base, we are needlessly pulling in an entire operating system. It comes packed with heavy utilities like Bash, curl, and Vim editors. I mean, ask yourself, do you really need Vim to run a Node server in production? Absolutely not. Plus, the way this baseline file is written, a simple source code change triggers a full reinstall of all your dependencies, and all of our raw development files are just getting dragged directly into production.
Moving right along to Section 2, choosing the right base image.
So how do we actually fix this? There's a stark contrast here. On the one side, we have our Ubuntu base image. It's overkill, heavy, packed with generic OS tools. On the other side, we have an Alpine, or Slim, base image. These Alpine images are purpose-built specifically for Docker environments. They're incredibly minimal and just ruthlessly strip out all those extra OS utilities that you simply do not need in a production container.
Now check this out. By making just one single change, swapping from Ubuntu to a Node 22 Alpine image, look at the immediate impact. Our image size plummets down to 258 megabytes. We've instantly cut the bloat by more than half just by picking a purpose-built base image. But hey, we're definitely not stopping there. Let's look at how we actually build the image itself.
That brings us to Section 3, proper use of layer caching.
To truly optimize things, you have to understand that Docker literally builds images layer by layer. It reads your Docker file line by line, and every single command creates a cache layer. In a really common, unoptimized approach, you pull the base image, then you use a command to copy all your source code and package files in at once, and then you run your npm install. But here is the trap. If you change even one single character in your source code, Docker says, the copy all layer changed, and invalidates the cache for everything below it. So a tiny little code edit forces a slow, agonizing 45-second full reinstall of all your Node modules. Not fun.
So the real trick here is that we must separate our steps to leverage that cache. Here's your actionable solution. Step 1. Only copy your package.json and package lock files first. Step 2. Run your heavy npm install. And Step 3. Only after that install is completely done do you copy the rest of your source code. By doing it this way, your heavy node_modules remain perfectly cached. You can tweak your app's source code all day long and Docker will just skip the install step entirely. It is a massive time saver.
I want you to burn this golden rule of layer caching into your brain. Frequent changes at the bottom, static changes at the top. Basically, things that rarely change, like your dependency lists, they go early in your Docker file. Things that change constantly, like your source code, they go at the very end.
All right, on to Section 4, using Docker Ignore.
Now let's talk about a remarkably simple but highly effective tool. If you are familiar with Git Ignore, you're going to feel right at home here. See, even if you write your Docker file perfectly, without a Docker Ignore file, you're still vulnerable. When you run a command to copy your current directory into Docker, it accidentally grabs the whole shebang. It grabs your massive local node_modules folder, local dist folders, hidden environment variables, and binaries, dragging them directly into your image build context. Just adding a simple .docker ignore file prevents this local development bloat from ever entering the image, keeping things secure and extremely lightweight.
And now for the grand finale, Section 5, the magic of multi-stage builds.
This is unequivocally the most powerful optimization technique for keeping your production environments perfectly clean. You know, a lot of clever developers will notice their final image has useless dev files in it, like raw TypeScript files. So they try to outsmart it by adding a command at the very end of their Docker file using rm-rf to delete those files after the build. But here is the trap. Because Docker works in layers, deleting a file in layer 6 doesn't remove it from layer 4 where it was copied in the first place. That data is permanently trapped in the underlying cache layers, still bloating up your final image size.
So, how do we bypass that? We use our ultimate solution, multi-stage builds. We basically break our Docker file into two distinct stages. Stage 1 is the builder. We literally name it as builder. Here we do all the dirty work. We install heavy compilers, copy all our raw source code, and build the app. Then we start stage 2, the runner. For this, we start completely fresh from a clean base image, and we literally only copy the finalized compiled output from stage 1, totally abandoning that messy builder environment.
To show you just how extreme this gets, let's look at a compiled language like Rust. In stage 1, our builder needs this massive 10 GB Rust compiler image just to compile the code. But in stage 2, our runner stage, we start from scratch, literally an empty image. We copy just the single compiled binary over from stage 1. The result, we completely toss out an 11 GB environment, leaving us with a microscopic final image containing absolutely nothing but the executable binary itself. I mean, that is the pure magic of multi-stage builds.
Bringing this back to our Node app, by using a multi-stage build, our final production image only contains these 4 essential items: the compiled dist folder, the necessary Node modules, the package.json, and the package log files. And that is it. Raw source code, TypeScript config files, heavy compilers, they have all been entirely eliminated from production. Looking at the final comparison, it's pretty incredible. Our initial unoptimized Ubuntu image sat at a sluggish 585 megabytes. But now, by utilizing an Alpine base, smart layer caching, Docker ignore, and the sheer power of multi-stage builds, we've stripped away hundreds of megabytes of bloat. The result is a lean, lightning-fast, highly secure, production-ready artifact.
Which brings us to our final thought. Are your production environments secretly harboring unoptimized, bloated code? I highly encourage you to go review your team's Docker files today. Check your base images, reorder your layers to really utilize that cache, and implement multi-stage builds. You're going to save space, speed up your pipelines, and dramatically improve your security posture. That wraps up today's explainer. Keep building, keep optimizing, and I'll catch you in the next one.